Welding plays an important role in many fields, including manufacturing cars, airplanes, and buildings. Without this kind of metalwork, we wouldn't have homes, gates, fences, small kitchen gadgets, cars, or even space travel. In this video, we will showcase 8 advanced welding techniques you've never heard of. If you don't want to miss any of these incredible innovations, keep watching the video. Number 1. Hyperbaric Welding. Learn all about underwater welding here if you've ever been curious. Unlike conventional welding, considerable pressure is used in this process. It repairs ships, oil platforms, pipes, and other steel structures buried in water often need hyperbaric welding. Waterproof electrodes are used in welding because they are optimal for environmental circumstances. The electric arc increases the temperature of the workpiece and the electrode, and other equipment provides a significant risk of electric shock. A gaseous bubble forms around the arc when the flux layer on the electrode decomposes, carrying the molten metal to the workpieces. The electric current propels metal droplets from the electrode to the treated surface. Because of how quickly joints cool in the water, it's crucial to emphasize how quickly this procedure needs to be finished. Number 2. Electron beam welding. In 1958, the first factory specializing in electron beam welding was founded. Today, this method is widely used in the aerospace and aviation industries to weld extremely reactive and refractory metals. Due to the kinetic energy of the electrons created by the beam, heating and welding are possible in instrument production and other analogous industries. A specialized electron gun produces the beam. When high-quality steel with the deep penetration is required for large metal projects, electron beam welding is employed. One of its advantages is that the molten metal is not saturated with gases. In addition, the high heat concentration enables the single-pass welding of metals up to 200 millimeters thick. The technique must be conducted in a specific vacuum chamber, and there may be a fusion deficit on the global path. Number 3. Laser beam welding. Laser beam welding is often the best solution when joining metal components for use in electronic or radio systems. Whether they are identical or dissimilar, it goes without saying that the laser is a source of power. Initially used in the 1960s when the first pulse and continuous wave laser systems became available. A focusing system focuses the laser beam to a narrower beam, which then travels toward the welding targets and is partially reflected back into the focusing system. Laser light penetrates the material, causing it to heat up and eventually melt. This is how welds are created, an oddly eco-friendly process compared to more common methods. Number 4. Gas welding. Gas welding is one of the simplest and most popular ways to combine multiple metal pieces. This is popular since the equipment is straightforward. There are gas or welding combinations for sale everywhere, and the energy source does not need to be particularly powerful. With gas welding, the metal is heated slowly and gently. Thus, this joining is only suitable for normal or non-standard tools, steel, non-ferrous metals, and cast iron. The metal must not exceed 5 millimeters in thickness. Either pay attention to the flame's white color. This means that a mixture of oxygen and fuel gas is utilized, and the welding techniques demonstrated in the video appear rather novel. The flame flux is precisely calibrated and produces outstanding adherence. Number 5. Friction welding. Aerospace and automotive industries employ friction welding to join metals and thermoplastics. Pressure is used to attach metal surfaces by bending the contact area. The rotation or movement of a component complicates welding. Friction warms the contact area and welds them directly. First, frictional force removes the surface's early oxide layers. Second, heat makes the material bendable. Initial touch fades rapidly. When pieces are pressed together, most plastic parts protrude from the connection. Third, reduce friction. The job is accomplished after welding joints. This spinning technology appeared in 1956 and expanded swiftly. Number 6. Exothermic Welding. In exothermic welding, the powder combination composed of aluminum or magnesium mill scale is known as thermite. Aluminum-based thermite is used to bind steel and cast iron components. This powder is utilized to heat the metal. In most instances, it is utilized to treat rail and pipe joints, weld cracks, and weld overlay. The pieces to be linked are treated with a refractory substance, heated, and then filled with melted thermite that has been fired and ignited again. In addition, the liquid iron created during the process melts with the main material to create a strong weld. Thermite based on magnesium is utilized to repair telephone and telegraph wires and all types of cables. Number 7. Forge Welding. Humans have never used this technology to make inseparable metal complexes. Ancient metal artifacts imply humans began forging approximately 400 BC. Modern forge welding uses hydraulic hammers and presses. This simple-looking welding has no benefits. After heating the metal, the tool impacts the shape of the weld surfaces. However, it's not easy. It requires a trained, skilled, and credible blacksmith. Low productivity and fragile joints plague this technique of welding. Few metals can be forged for these reasons. Its principal usage is in severe locations where advanced technology isn't available. All parts must be low-carbon structural steel. Carbon percentages above 0.3% impair weldability. Number 8. Submerged Arc Welding. This welding method is utilized in a stationary workshop and applies to all metals and alloys. Electric arc welding is performed on materials ranging in thickness from 1.5 to 150 millimeters. Between the end of the welding wire and the metal to be welded, it burns beneath the flux layer. Special mechanics automatically construct the electrode cable and the arc. One contact conducts the wire's welding currents, while the other is connected to the metal. This form of welding demonstrates increased productivity and minimum metal losses. In addition, the welding zone is maximally shielded. Since the arc burns beneath the flux layer, there is no light splashing and no need for light protection devices. And that completes our video for today. We hope you enjoyed learning the advanced welding techniques you've never heard of. Which of them are you most excited about? Tell us in the comments below. Thank you for watching. Don't forget to like this video and subscribe to our channel for more content such as this.